guys, in the previous class, we have started already STA part 1. STA is nothing but static timing analysis, and in that we have completed a part 1. So first, let me see what is a recapitulation. Recapitulation is nothing but what we have done in a previous class. So what all we have done? We have done difference between static STA and dynamic STA. Next, what we use, what is use of static STA instead of dynamic. That means why we are using static STA instead of dynamic STA. Defining of STA, main steps of STA. That means what all the main step STA does, and inputs and outputs of STA. That means what all the inputs and outputs we are having for the STA. So these was a recapitulation which we have done in a previous class. Mainly first we have to know what is the meaning of STA. Already we have learned that what is an STA. STA is nothing but it will add or it will calculate all the total net delay, cell delay and all the delays, and that is considered to be as STA. So what all the main steps were involved in the STA. So what the STA does here. So first the STA takes a possible timing path, and it will check and it will check for the timing path. So after checking what the STA tool does, it will break the timing paths. That means it will break into a small parts. Why it will break? To calculate a timing path or to calculate the delay, it becomes easy. So that's why it will break into a small timing path. And after breaking it into a small timing path, what the STA do? It will check for each and every path the timing violation, whether it is met or not. That is the main step what the STA does. Now next, what are the inputs and outputs of STA we are having? Inputs we are having like netlist, STC and library files are the inputs for the STA. And what are the outputs will be getting? RC, that means constraints will be getting, and some of the constraints will be getting in the STA. These are the outputs of STA. So this was the topic which we have seen in the previous class. So today let me tell you regarding timing reports. What are the timing reports? See here, STA is mainly about calculating the timing, right? So timing, in a sense, we, even a human being, manually we will know that to know the time or to see the time. But here when it comes for the VLSI background, the timing reports should be analyzed in the form of a reports. So how do we analyze? See, this is the timing report which you can see in the slide, and each timing report was divided into 4 parts. Each timing reports were divided into 4 parts: header, data arrival, data required, and slack. So each and every timing report, whatever the timing report it is there, and that timing report is divided into 4 parts. What are those 4 parts? Header, data arrival, data required, as well as slack. So first, when we come for the header, here we can see in header what all the steps we are having: start point, end point, path group, path type. So these are the 4 points we are having header. What is the meaning of start point? Start point is nothing but we can say it is an input, or we can say it is
Can
a
go to the
source
horizontal
side.
view or horizontal view.
Yeah, horizontal only. It's okay, fine. It
Yeah.
had come. So what is the start point? We can say here the start point is nothing but we can consider it as an input or else a source, and that is a start point. And what is an endpoint? Endpoint is nothing but destination clock, or endpoint is nothing but output. This is the start point and endpoint considers. Next, path group. That means the particular path, in which path it is going. It is a clock path, F clock path, SOC clock path. We'll be having different clocks when we come for the industrial project. We'll be having different clock. No? So in which type of clock, in which path group the given timing path is going, to check that, to identify that this path group indicates. Next, path type. What is a path type? Maximum or minimum. Maximum is nothing but setup, minimum is nothing but hold. That we can understand here. So we will be having a question like, how can you identify in which the path is going on, in which the path is going on? You can say by seeing the timing report, we are having an option called path group, and in that path group we can know in which path group that the timing or that the path is traveling. then next, after seeing this timing report, how can you say whether this timing report is setup one or whether this timing report is a hold one? How can you say? With the help of path type. So if you see path type, if it is a maximum, it is a setup. If it is a minimum, it is a hold. That like that you can consider whether you what in which path group and in which path type it is there, and the start point from which flop it is starting and from which flop it is ending. Everything will be there in the header section. Next, the second section is like data arrival. So what all the data will be, what all the data arrival content consist of is that it will have the clock network delays, F1 clock, F2 clock, U2, U3, and data arrival time, increasing path, in which path it is going, all that means in which way the data is arriving, and which here you can see here data required. That means what all the data is required, library setup, data required time, clock, network delay, everything will be present in the data required. And next finally is slack. Slack is very important concept for the timing reports, because at last if we calculate this only, we will be knowing whether the particular path or whether the particular thing was met the slack or not. If the slack met, that means it is very useful and we can go for the next step. If the slack didn't meet, we have to check why the slack didn't meet. So that's why this is the last part, that is nothing but slack, and it is very important part in the timing required. So what the slack does, it will calculate for data required, data arrival. So what is the data required? Total value it will calculate, minus, and data arrived it will calculate. So finally we'll be getting one value, and that is slack, that is 2.92 or 3.9, whatever it is, we'll be getting. No, if it is a positive, then nothing, positive is nothing but the slack got met. If it is a negative, that means the slack didn't meet. So that, like that, in that sense we can say that these timing report or these path was very good for working. If the slack met, we can say the path was very good for working. If the slack didn't meet, then we can say that we can say that it is not good for going for the next procedure. So this is the timing report. So in timing report, how many parts will be having? 4 parts will be having: header, data arrival, data required, and slack. So what the header consists? It consists of start point, end point, path group, path type. That means in which path group it's going and which path type it is there. Next, what is data arrival? In data arrival, we'll be having in which clock it is rising edge, network delay, flip flops, data arrival time, everything will be present in the data arrival. Data required, library setup, data required, everything will be there in data required. Next, finally we have to calculate slack. And how do we calculate slack? We will be calculating slack with the help of data required time as well as arrival time. So here in the next below the slide of the timing report, I have explained you very clearly that what the header contains, what the data level contains, what the data required contains, and what the slack. So first let me explain you what is a slack. What is a slack? Slack is nothing but it is defined as the difference between required time and arrival time. It is just a difference between the required and arrival time. So how can we write the equation? Slack is equals to arrival time minus required time. So we are having different types of slacks like positive slack, negative slack, and zero slack. So what is the meaning of positive slack? Positive slack means nothing but the signal arrives earlier than the required and something in the margin. That means it will arrive. See, if we are having, for example, we are having 4 nanosecond, it is a required time. If the signal arrives before the 4 nanosecond, that is said to be as a positive slack. Or else you can say very easily, if the value was positive, we can say as a positive slack, but that is not correct. For remembering, we can say like that, but that is not correct. The actual correct one is like the signal arrives before and required, where the signal arrives earlier than required margin is known as positive slack. Positive slack is nothing but the timing report was correct. We can say whether the timing got met, and we can say that the timing report was correct. Next, negative slack. So what is a negative slack here? Negative slack is nothing but the signal arrives later than the required time. That means, for example, I want the signal should arrive at 4 nanoseconds or 4 picosecond. But what it does, if the signal arrives after 4 nanosecond, that means if it arrives for 6 nanosecond, here when we subtract, we'll be getting a negative value, right? So that is said to be as a negative slack. For remembrance, we can say if we get a value negative, that we can say as negative slack. But when it comes for an interview question, you should not say like that. We have to say that negative slack is nothing but the signal arrives later than the required time. So if we are having a particular required time, so if it arrives after the required time, and that it's said to be a negative slack, there the timing violation starts. So we have to check why the negative where the negative what is the chance of getting negative, whether it's the use of a net delay, or if we are having a lot of MVT cells or LVT cells, there also we can get lots of net delay, and that leads to negative slack. Like that, we have to analyze the timing report so that we will be know where the mistake have gone, and afterwards we have to change it. Next, and the third one is zero slack. Zero slack is nothing but the signal arrives exactly at the required time. That means if I have a required time, that means if I have a required times of 4 nanoseconds, if the signal also arrives at 4 nanoseconds, at that time what we get a value, arrive time minus required time, 4 minus 4, what we get, 4 minus 4 is nothing but 0. 0 in the sense it is a zero slack. So these are the three types of slack: positive slack, negative slack, and zero slack. Here the question, here the slack is equals to arrival time minus required time I have given you, but it is wrong. By mistake, I just typed there. It is required time minus arrival time. Okay, na? It is the difference between the required time minus arrival time. Required time, then after we have to minus it from the arrival time. There you have to change. I just typed it wrongly. Just do it a correction. So how many types of slack we are having? 3 types of slacks: positive slack, negative slack, and zero slack. So what is a positive slack? Positive slack is nothing but the signals arrive earlier than the required, and something in the margin is said to be positive slack. What is a negative slack? That means if the signal arrives at the later than the required time, it leads to a timing violation, that is negative slack. And what is zero slack? Zero slack is nothing but the signal arrives exactly at the required time, there is no any timing margin, that is said to be as a zero slack. See, here you can see the timing diagram for the positive slack as well as negative slack. Here positive slack, setup slack. Set, that means here we are having a positive and setup. This was the clock and this was the positive slack. What I said positive slack in the sense we have the signal arrives before the required time. So here we can see here the slack setup, the signal should arrive till here. The black one you can see here. That means before a required time, we had the signal got arrived. This is regarding with the setup and hold time. So in the next part, I'll be explaining regarding setup and hold time. There I can explain you this timing diagram. For now, this timing diagram is not required. When I go for the setup and hold in the detail, when to add a skew, when we should remove a skew, what is the meaning of slow path, what is the meaning of fast path, everything I'll be giving you in the third part. So when I go for the third part, I will explain you this timing diagram. So in this today's topic, what all we have discussed regarding the timing report, and in timing report how many parts are there, and what are the data information was present in the timing report, and next what are slack, and next what are the types of slack. These are the things we have discussed in the today's class. If anyone are having any doubts, raise the question so that if you have any doubt, I'll just clarify it.
Hello, ma'am.
Yes.
Hello. So
Yes,
what is the letter R in the timing diagram, ma'am? After the numbers, right? There is somewhere we are getting R.
R. Wait. 1 minute. Let me say you. Let me see. Where we have R. Yeah, it's a rising edge. R is nothing but it is a rising edge. At the rising edge, we are having that particular time or particular value. R is nothing but it's a rising edge.
Okay, ma'am. Got it. Thank you.
You can see here in the header section, in the header section itself, we will know whether the clock or whether the signal it is passing in a rising edge or falling edge. If it is in the rising edge in the start and end point, so we'll be getting values of all in the rising edge. That is only R.
Okay, ma'am. Got it. Thank you.